So till now we have seen one kind of questions where we are counting number of A's or number of B's, and even we have seen mod counters, which means number of A mod 2, number of B's mod 3, and that is one kind of question. And other kind of interesting question is if sigma equal to 0 comma 1, if sigma contains some numbers 0 comma 1, and if I form a string, now that string can be interpreted as a number itself. So that is interesting. See this question, we shall understand it. Construct a minimal DFA which accepts set of all strings over 0 comma 1, which when interpreted as binary number is divisible by 2, which means if the sigma equal to 0 comma 1, among all the strings which are possible over 0 comma 1, strings that are all possible over 0 comma 1, if I take any string 1100, if I take any string and if I interpret as a binary number, if this is considered to be a binary number, what is its value in decimal? Its value in decimal is 6, right? If I consider it as a binary number, that should be divisible by 2. So before solving this question, I want to discuss about number system, not the entire number system. I want to discuss some few important points which will help you solve such kind of questions easily. So I want to discuss few points here. So what is a number system? Number system is nothing but using numbers for counting things. Let's go back to ancient times. What do you think is the first number system that is being used by human beings? So first number system is actually unary number system. People, they used to use stones in order to count the number of things, or let us say cattle. If they have 100 cattle, then they use 100 stones, just to remember that they have these many cattle, and when they are letting out, they will keep the stones separate, and when they are letting the cattle in, they will again count the number of stones and they will match against the number of cows. That is unary number system. And unary number system contains only one number, which is 0. And if I write 0 like this, this is actually 1 in decimal. If I write 2 zeros, it is actually 2 in decimal. If I write 3 zeros, it is actually 3 in decimal. So you can even you might have played this abacus when you are in school, right? So it is nothing but using number of stones to represent the number. So unary is going to contain only one symbol, which is 0. And the next popular number system is, after unary, the next popular number system is decimal number system. So if you look at decimal number system, why do you think that the next popular, or why do you think we have invented the decimal number system with base 10 before inventing binary or before inventing octal number system? The reason is simple. We have 10 fingers, so we can count 10 things. That is why we have 10 digits, 10 fingers and 10 things, right? 0, 1, 2, 3, so on 9. So decimal is going to contain 10 digits, and so it is also called as base 10. And the other number system is, one is binary. Binary has 2 digits, 0 and 1. And then ternary has 3, 0, 1, 2. This is base 1, this is base 2, this is base 3, this is base 10, so on. Hexadecimal, which is base 16. So it is going to be 0, 1, 16 symbols, 0, 1 to 9, and then A to F. This is hexa. So we shall see some interesting points about these number systems. Let us see some interesting point about binary number system. So first thing is, in binary number system, how are numbers formed and how are they validated? Let us write 1. And if I concatenate anything to the right of it, like this, I am writing 1 and I am concatenating 2 to the right of it. Now it is going to be 12. How did we get this 12 is, we will take the existing number 1 and multiply with the base. What is the base here? Base is 10, and then add the number to it. That is how I got 12. This is very important point. I am going to extend this to other number systems as well. Now if there is 12, if I write 3 here, it is going to be 123. How did we get this? Take the existing number 12 and multiply with the base 10 and add the new number 3, that equal to 123, right? Or you can even take 1 4 5 6, right? Let's see how to evaluate this. I'll take the existing number, first digit 1, and I multiply with the base 10 and I add 4, that is how I got 14. So this one is 14. Now I'll take 14 and I multiply with base 10 and I add 5, next one, that is how I got 145. And I'll take 145 and I multiply with base 10 and then I add 6, it is going to be 1456. So that is how all the numbers in base 10 have to be evaluated. Now let's extend this same method to other bases also. Let us say to binary. Let us say the number is 1 0. Now what is its decimal value? Take the 1, multiply with base and add the next one, which is nothing but 2. So 1 0 is 2, like this. Let us say I have 1 0 1. Now you take the first one, 1, multiply with 2 and you add 0. This is going to be 2, which means these first 2 digits are going to be 2. Now you take this 2 and you multiply with base and you add this one, so it is going to be 5. Understood this? Which is nothing but, if I concatenate any number to the right of a number, then I can form the entire number using this method. Let us take few more examples about few other number systems and let me explain this clearly. Okay, so I want to go with binary number system first. I'll explain binary number system and then we shall go to ternary, and once you understand everything, we can easily solve the questions here. Now binary number system. Let us say I have a very big digit 1 0 1 1 0 1. So how to evaluate it is, first take the first one, which is 1, and you multiply with base, which is 2, and you add the next one plus 0. The result is going to be 2, which means these 2 digits are going to be 2 in decimal. Okay, now you take 2 and you multiply with base. Always remember, I am multiplying with base, and you add the next digit, next one, it is going to be 5. Okay, now this 3 is going to be 5. Now you take this 5, multiply with 2 and again add the next one, which is nothing but 11, right? And the entire thing is going to be, this entire number is going to be 11, and now you multiply with 2 and you add the next digit, which is 0. So this entire thing is going to be 22. Now you take 22, multiply with 2 and you add the next digit plus 1, that is going to be, I think, 45. So this entire number is going to be 45. So you can do it this way. This way it is very easy to understand too. See this, let us say 1 0 1 1 1 1. This is 1, this is 1 into 2 plus 0, which is 2, and this is 2 into 2 plus 1, which is 5, and this is 5 into 2 plus 1, which is 11, and this is 11 into 2 plus 1, which is nothing but 23, and finally this is 23 into 2 plus 1, which should be 47. So that is the number given, right? You can even extend it to ternary numbers also. Let us say a ternary number. So what are the number of digits or what are the valid symbols in a ternary number system? Always remember, if the base is some n, then it will have n number of symbols in it. If the base is 3, then it will have 3 symbols, 0 1 2, 0 2 3 minus 1. if the base is some n, then it will have 0 to n minus 1. These are the symbols. Okay, so now let us say I have a number 0, or let me say 1 0 1 2 or 101 in ternary. Then what is its decimal value? First take the first one, and you multiply with the base. What is the base here? Base is nothing but 3. Why? Because it is ternary number. I am talking about ternary number, and you add the next one, which is 0. So the entire thing is going to be 3, which means 10 is nothing but 3. Now after this, take this and again multiply with 3, which is nothing but the base, and again you add the next one, so which is 10. Understood this? So if I have a number, binary number, I can convert it into decimal this way, and if I have a ternary number, I can convert it to decimal this way. So just answer this. If I have a string of some number of digits, and if I append a symbol to the right of it, then first you convert this entire thing into decimal, then you multiply the result. Let us say the result is r, this entire thing is small r in decimal, then you multiply the result with the base of the number system, whatever this number system is in, plus you add the next one. That is how you will get the final number. See again, let us say I have number 1 2 3 4, then it is nothing but you can take this one, the entire 1 2 3 and you multiply with the base 10 and you add 4. That is how you can apply. So using the recursion, this entire string can be evaluated. Like 1 2 3 and 4, and again 1 2 3 can be evaluated as 1 2 and 3, and again 1 2 can be evaluated as like this. Understood? So first I will take this and add this, take this, multiply with base and add this, take this, multiply with base and add this, take this, multiply with base and add this. So that is how all the numbers can be formed. So if I append any number to the right of a string already existing, just take the value of that string, multiply with the base and add the number. That is how we are going to do it. Okay. Now let us get back to the problem. The problem is, the number system is binary. Why? The digits used are 0 and 1, and now they wanted to find all the numbers or accept all the numbers which one divided by 2 or which are divided by 2. Okay. So first thing is, when I divide any number with 2, how many reminders do I get? When I divide any number with 2, how many reminders do I get? So one remainder is 0 and other remainder is 1. So I get 2 reminders if I divide any number with 2. Now let us start with this. So this is the basic way. So I can classify all the strings, all the binary numbers into 2 classes. One is when divided by 2, they will generate 0 as the remainder, and the other class is when divided by 2, they will generate 1 as the remainder. For example, if I have 0 0 0 0, then it is going to be 0 0 0 0 1 0 0 0 1 0, then it is again going to be even number. Why? Because it is ending with 0. If I have 1 or 1 1 or 0 1 1 or 1 0 1, they are all having ending with 1, therefore they are going to generate a remainder of 1 when divided by 2. So let us see how I can draw it. I am in state 0 without seeing anything. If I see a 0, the total number I have seen till now is only 0, right? So if I see 0 and if I divide it with 2, the remainder is going to be 0. Therefore on Q0, on 0 I am going to stay here. Now if I see a 1 on Q0, if I divide it with 2, the remainder is going to be 1. Therefore on 1 I will be moving here. Now let us say I am in Q1. How did I reach Q1? You have already seen 1 and you have moved to Q1, and if you see a 0 to the right of it, it is nothing but 2. And what is 2? 2 divided by 2, remainder is 0. Therefore, on seeing 0, I'll come back. Is this DFA? No. Q1 is not complete on 1. Let us say I am in state Q1. How did I reach Q1? On looking at 1. So after it, if I see any number of 1s, let us say if I get 1, 1, the entire number is going to be 3, 1, 1 is going to be 3, which one divided by 2 is going to generate a remainder of 1. Therefore, on seeing 1, I'll be here. So just think about it. How did I design everything? We shall just revise. First thing is, the question is about divisible by 2. When I divide any number by 2, I get two possible states. One state indicates the remainder is 0, other state indicates remainder is 1. Let us assume that I am in the first state. When I am in the first state, if I see 0 for the first time, then it is nothing but simply a 0 which is divisible by 2. Therefore, I stay here. If I see a 1 in Q0, which means initially I am seeing 1, which is nothing but when I divide by 1, I should be going to 1. Fine. So what is the state that you have to accept? They have to be divisible by 2, which means remainder should be 0. Therefore, this is the answer.